Today we're going to learn how to factor using a method called grouping. And so you have to really understand factoring by pulling out a GCF first. So if I take a look at this very first problem, if I tell you to factor this, if you look at it, there is a GCF. Both of these terms have an x in common, right? So I'm going to pull out the x. And so I write down the x, and I divide out the x, and I'm left with 3a minus 7b, right? So now in example 2, the only thing that's different in example 2 is I've now just replaced the x. See, over here where I have an x and over here where I have an x, I replaced the x with the expression 2a plus 5b. 2a plus 5b. So if I'm asking you to look at this as a whole and ask you to pull out the GCF, well, the GCF is this, 2a plus 5b, in both of these terms. The GCF is 2a plus 5b. So I would pull out the 2a plus 5b, just like I did over here with the x. You pulled out the x. It hangs out on the outside of the parentheses, right? Here, I'm pulling out the 2a plus 5b. And then once I pull that out and I divide both of those terms by 2a plus 5b, I'm going to be left with 3a minus 7b. So now, looking at example 3, if I ask you to multiply these two binomials together, well, just think about, typically we would do FOIL, right? I would do 2a times 5b, and then 2a times 2, and then 3 times 5b, and then 3 times 2. So now I want you to just look at it a different way, right? The 2a has to get multiplied by both of these terms. So couldn't I write this out as 2a, and then in parentheses, that 2a has to get multiplied by 5b and the 2. So isn't that the same as writing 5b plus 2? Like that. And then this term has to get multiplied, the 3 has to get multiplied by 5b and 2 again. So I could say, oh, that's just the same as doing plus 3 times 5b plus 2. And so if instead of like writing out FOIL, what if I did it this way? You would get 2a times 5b would give us 10ab. And then 2a times 2 is 4a. And then 3 times 5b is 15b. And then 3 times 2 is 6. This is the same result that you would get if you multiplied just using FOIL, right? So now let's take a look at the problem. This answer is right here at the top. Let's look at it and work it backwards. So if you think about this, I could just group this together, right? And I could group this together. The associative property says that I'm allowed to do that. If I look at the first group, well, what's the GCF of the first two numbers? Well, it's 2a, right? 10 and 4 have 2 in common, and they both have an a. If I divide out a 2a, I'm left with 5b plus 2. The second set, if I pull out a 3, because that's the GCF, I'm left with a 5b plus 2. So now if you take a look at what I have, my GCF is 5b plus 2. I can pull that out to give me 5b plus 2, and then I'm left with 2a plus 3. This is called factoring by grouping. So if you take a look, these are the factors of that, right? This was the problem. I ended up with that. I went backwards and I got the factors. So let's take a look at a few more. So to do factor by grouping, you set up you group the first two together, then you group up the last two, and you pull out the GCF. So the GCF here of 16a to the third and 16a squared is going to be 2a squared, right? When I pull out the 2a squared, I'm going to be left with 8a plus 3. And then I do the next one. The GCF of 40a plus 15 is 5. So I'm going to pull out a 5, and I'm going to be left with 8a plus 3. And so if you take a look, my GCF of both of these terms is 8a plus 3. So if I pull that out, 8a plus 3, I'll be left with 2a squared plus 5. And if you went ahead and did FOIL with this problem, it will lead you right back to that. So those are my two factors. Now let's take a look at the next one. Now the next one, a little bit different because there's a subtraction sign in there, right? So when I group it, I'm going to group these together. And then the minus side, it needs to hang out with the 14. And really, that's allowed because I'm allowed to change subtraction to plus a negative, right? So I technically am changing that minus sign to plus a negative. And remember, when your first term is negative, you have to pull out a negative GCF. All right, so take a look at this first one. The first term here is positive, so I'm going to pull out a 3x, because that's my GCF. What's left when I pull out a 3x is 2x plus 3y. In the next set of parentheses, my GCF, I'm actually going to pull out a negative 7. So you pull out a negative 7, and when you do that, divide each of those terms by negative 7, you're going to be left with negative 14x divided by negative 7 is positive 2x, and negative 21y divided by negative 7 is positive 3y. And if you look, I have 2x plus 3y again as my GCF, so I pull that out. I make that 2x plus 3y. And then when you're left inside what's left after that is 3x minus 7. Pretty cool, huh? Let's try a few. All right, feel free to go ahead and stop the video and try these if you want to, but I'm going to walk you through them. So in this one, I'm going to put the first two terms together and the last two terms together. I'm going to pull out the GCF. So the GCF here is 4x. If you divide both of those terms by 4x, 12xy divided by 4x is 3x, or 3y, my bad. And then negative 4x divided by 4x is negative 1. And then in the next set of parentheses, the GCF of 21y and 7 is 7, right? So I'm going to pull out a 7. 21y divided by 7 is 3y. And 7 divided by 7, or negative 7 divided by 7, is 3y minus 1. So now if you take a look, this 3y minus 1, those are your GCF. So you pull out that 3y minus 1, you're left with 4x plus 7. And there you go. Those are your factors. Okay? Trying the next one. So the next one, I'm going to put these two terms together. And then notice that negative 18, it has to go with, the minus sign has to go with the negative 18 because I'm changing that really to plus a negative. So I pull out, in the first term, the only thing that they have in common is they've got p squared in common. So you pull out a p squared. I'm taking away a p squared from each of those terms to leave me with 2p plus 5. In the next set of parentheses, the GCF here is negative 9. I'm pulling out a negative 9 because that negative 18p is negative, right? So you got to pull out a negative 9. And then you're left with positive 2p plus 5 because negative 18p divided by negative 9 is positive 2p, and negative 45 divided by negative 9 is positive 5p. My GCF of both of these terms is 2p plus 5, right? So I'm left with a 2p plus 5, and then what's left on the inside is p squared minus 9. Now, there's something crazy going on with this one, right? If you remember what we learned about differences of squares, this right here is a difference of squares. It's a perfect square minus a perfect square. So that can go further, right? This 2p minus 5, I'm just going to bring it straight down because I can't do anything with that. But p squared minus 9, remember, can be p plus 3 times p minus 3. I would go ahead and put a star by this problem because that doesn't happen very often, but when it does, you have to pay attention to it, right? If you were to check this, it doesn't matter. What I personally would do is I would just multiply these together to get that, and then do FOIL here. It'll bring me back to the original problem. But you could, if you wanted to, you could do FOIL with these two, and then you multiply this by what you have left over here. It'll still bring you right back to that problem. So you always can check your answers by going through and doing FOIL. Let's do two more together. Again, feel free to stop the video and just chime in to see if you did it correctly. That's totally fine. So the next one, we're going to put 6x to the third and 5x squared together, and we're going to put 2x minus 5 together. So in the first set of parentheses, my GCF here is 3x squared. Don't forget to pull out the variables that they have in common. When you do that, you're left with 2x minus 5. The next set, there is no GCF there. We typically, if that was all by itself, we wouldn't pull out a 1, but because we're trying to factor by grouping, we need to pull out a 1. So we're going to put a plus 1 here. When I divide this whole thing by 1, you're still left with 2x minus 5. So the reason you need that 1 there is because you need it in order to be able to pull out that as a GCF. It has to be multiplied by something. So you pull out the 2x minus 5, and then you're left with 3x squared plus 1. Now you might be like, well, can this go further? A reminder, that can't go further because it's not a perfect square minus a perfect square. So we're done. That's 2x minus 5 and 3x squared plus 1. I would definitely try this next one by stopping the video and just seeing, can you do it? All right, so here we go. This one, you put these together. You put these together. It's really because you're changing that to plus a negative, and we want that negative sign in there with that second set of parentheses. In this one, it's 9x squared that we're pulling out. When you pull out the 9x squared, you're left with x plus 1. Here you pull out a negative 4. When you pull out the negative 4, you're left with x plus 1. So now the GCF of these two terms is x plus 1. So I've got to pull that out, put it out front, x plus 1. And then you're left with 9x squared minus 4. This is a perfect square minus a perfect square. It's a difference of squares, so you have to take it further. So I'm going to bring down my x plus 1, and I'm going to break up 9x squared plus 4 into 3x plus 4 times 3x minus 4. And you're done. Those are your factors. All right, good luck with the rest. Let me know if you have any questions.